So we've been looking at taking derivatives of inverse trigonometric functions. We derived some of those formulas yesterday. I showed a video of tricks on how we can memorize these formulas. We did some problems, and now I wanted to do another example. And this example says that we have sine inverse of the quantity x plus y. And then we have plus cosine inverse of that quantity x minus y is equal to 5 pi over 6. We want to use implicit differentiation to find dy dx at the point 0, 1/2. So there's a couple ways that we can start this. We can use these formulas right away and take the derivative of each piece. And so I'm going to take the derivative of sine inverse of that quantity x plus y. We're going to have to use the chain rule here with implicit differentiation. So we're thinking of our outer function to be this sine inverse of this quantity. And so if I'm looking at the derivative of sine inverse, that was 1 all over. We had, because this was an S, they talked about it was a minus in between the two quantities, and we had the square root, which we can think of as a funny kind of S shape, was one way to remember this. And it was 1 minus, this is the inside of our function x plus y, times that derivative of the inside. So if I look at the derivative of x plus y, well, the derivative of x is 1, plus the derivative of y is 1, but y is a function of x. So that's where we had to put times dy dx. Okay, so that was the derivative of the first piece, plus the derivative of cosine. So cosine was one that was similar to sine, except the only difference was there was a -1 instead. And so again, we're going to be using this chain rule here. So cosine inverse, that would be -1 all over the square root of 1 minus the inside, which in this case is x minus y, times the derivative of this inside. So again, we're going to be looking at the derivative of x, which is 1, minus the derivative of y is 1. And again, y is a function of x, so times dy dx. This is equal to derivative of a constant 5 pi 6. That's just 0. Okay, so we want to find out what dy dx is here. And we want to find this out at this point. So we know our x value of this point is 0, and we know what our y value is of this point. Our y value is 1/2. I could go ahead and just try to solve for dy dx first, or I might be able to make this a little bit more interesting or easier by just going in and plugging in our values. Just pause for a sec. So with me trying to memorize this formula of what we learned, I forgot to put in, you guys caught me, thank you, this x quantity squared, x quantity squared. So let's go back in there and put that in. So quantity squared, quantity squared. So we're going to go in now and plug in those values for x and y. And let's just simplify this down. I think that, again, this will help us. And so, and this we can think of as over. So this would be 1 plus dy dx all over, I'm going to put the square root of 1 minus. Now we're going to plug in what our x value is, which is 0, plus our y value, which we said was 1/2. And we're going to square that quantity. So that was just this piece. And then I'm going to pull my minus sign out front. So minus, do I want to pull that out front? Let's keep it as plus, actually. Let's distribute this negative inside here. So that will give me in the numerator a -1 plus dy dx all over the square root of 1 minus, and again, let's go back in and plug in what our x and y value is. X is 0 in this case, minus the y value, which is 1/2. We're going to square that quantity, and this is equal to 0. Okay, so 1 plus dy dx, which we're trying to solve for, all over the square root of 1 minus, well, if I square 1/2, 1/2 times 1/2 is 1/4. Plus this -1 plus dy dx, which we're going to be trying to get by itself in a minute, all over the square root of 1 minus, again, here I have -1/2, but that is quantity squared, so that's going to give me a positive 1/4. So 1 minus 1/4 equals 0. Well, I know 1 minus 1/4 is 3/4. And so this gives me 1 plus dy dx all over the square root of 3/4. But that's the same thing as the square root of 3 all over the square root of 4. You can even take that a little further, right? Square root of 4 we know is 2. So when we write this other one, we have plus -1 plus dy dx all over the square root of 3 over 2 equals 0. So let's invert multiply so we can get rid of this complex fraction. So we can think of the top piece we wanted to. We have to put parentheses around that whole piece, this 1 plus dy dx. Or another thing, I was also thinking that we could also just multiply both sides of our equation. We could clear our fractions, right? Another way to do that. If we multiply both sides of our equation by square root of 3 all over 2, notice that's going to cancel with this piece. When we distribute over here, that's going to cancel. And so 0 times anything is 0. So we're left with 1 plus dy dx and then we have this -1 plus dy dx is equal to 0. If I combine like terms here, 1 minus 1 cancels. We have dy dx plus dy dx. That's 2 of those. 2 dy dx is equal to 0. So if I get dy dx by itself and I divide both sides by 2, 0 divided by 2 is still 0. And so I find that the derivative of y with respect to x at that point is 0. Let me see if there's any questions on that.